Welcome back to a much awaited video. This is exploiting a vulnerable API. In this one, we're going to be covering IDOR, which is insecure direct object reference. What's up, guys? This is Ryan from elevatecyber. Yeah, I had a lot of fun making this one. It was it's really cool to think on the dev side on how to actually build these things, and I feel like it has given me a new understanding of this stuff as well. But IDOR is a pretty simple vulnerability to understand. You can see this in web apps as well as APIs. Basically what it is you're able to guess an ID. Maybe it's just incrementing by 1, and you can access sensitive information. The key is sensitive information, though. Information you shouldn't have access to. Let's just put it that way. So I've added a bit more to the API from last time. I've added a number of functions to it. What we added was to the account class here. The users one was more of a test endpoint, but I added to the account in this case. And I'm not going to show you what I added just yet. We're gonna play this out like a scenario here, right? So obviously we have all the answers because we created it, but we're gonna, you guys don't know every little detail perhaps, so we're just gonna step through this like a simulated scenario, if you will. Let's pretend that we have an account on this website and it has an API, and we are Bob Lucas. That's us, and we have an ID right here. And this ID is our user ID, and we can access information. And obviously, there's some sensitive information here. We got our social security number, our address. We have all our information, our personal information here. And this is how we are stored in the database and then served up on the API. So with this accounts endpoint, I have to know the user ID to get my information, right? So if I don't supply anything, I added some error handling in here, and it says, hey, this is a bad request. Ensure you query something with the UID parameter. So if I go and do that, but let's just say I enter an invalid one, then I'll just get null. I won't get anything back. So going back to the code, here's the error handling. So it will grab the arguments and stored in the args variable, and it will look for an argument called UID, and then it will call find account passing in the UID, and then it will return that as JSON basically. And if there's nothing in there, right, you'll hit an exception, and then you will print out the error. I created this errors.json. Right now I have the 400 error for here, and I can keep adding in more errors and then call the appropriate error when it occurs. So just thinking a bit ahead here by creating that. So yeah, that's basically what you need to know here. But one thing that's always good to do is if we notice here, right, we had our UID, an ID that we know, but let's say we don't know the UIDs of the other users on this system, right? And obviously, as we can see here, right, there's personal identifiable information. So we could get some good stuff here if we are able to exploit this. And I'm just kind of looking over on my second monitor here. It looks a little bit small, so I'll zoom in extra hard for you guys that say that it's hard to see in some of these things. So now this is humongous. This is literally huge. So yeah, personal identifiable information. One good thing to check when you have IDs is always to increment the number by 1 to see if you can access another user's information. Same thing if you're approaching a web app, right? You see something and it's like sensitive information, there's an ID, try incrementing it by 1, see what happens. So in this case, we'll change the 14 to a 15, and oh, now I get someone else's information, right? And the social security and all that. And you can keep going, so on and so forth. But, we're efficient hackers here, right, at elevatecyber. So we're going to actually create our own exploit script to exploit this vulnerable API, right? Because I shouldn't be able to access these guys if I just type in something random. I don't get anything. I would have to know their UID, but they're auto-incrementing, and so that's not a secure way for them to be implementing this API. So let's go ahead and create our custom exploit for this API in particular here. And we can do all that using the request module. So this is putting together some of the Black Hat Python stuff we're learning. You know, we're actively learning that in that series. Go ahead and check out those videos if you haven't already. I'll link them at the end of this one. But yeah, just applying what we learn, right? We're learning a lot of Black Hat ways to exploit stuff. Let's apply that. Let's exploit this API here that is most definitely vulnerable. So how would we do that? Well, let's create a file. We'll just call it exploit.py. And we will import requests, of course. And what I'm going to do from here is I'm going to say that, you know, we'll define, you know, we'll do this the really prim and proper, excellent code, clean code way. We'll write classes and functions for the class and all of that stuff, right? So if we define a class, we'll just call it API, and we'll have our init function, of course, first off. And our API is going to have, well, of course, it's going to have to take in self as a parameter. And it's going to have an init function. We're going to initialize the URL, right? Because it's going to have an endpoint that we're trying to hit, obviously. So in our case, I just know that the API that we're hitting there was this one right here on port 5000. And it was the accounts endpoint. And we'll leave that alone right now. We'll add the parameters separately, right? So if we write a function, we'll just call this pwn because that's exactly what we're doing. We're going to pwn this API. We're going to call api.pwn and pwn this API. So let's do it, right? Let's say we want to brute force up to 50. Up to 50, right? If there ends up being more, then we can always expand this later on, no problem, right? So we'll say for I in range 50. Now, we'll define a variable. We'll call it UID, and remember, we know our UID. We know where this thing is starting, right? So we can go ahead and pass in this here, right? Plus I. And that will ensure that each time we're adding 1 to our UID, right? Every time. It's going to start at 0, so it'll pull us up. So yeah, that's fine. And then it'll just keep going from there. Right, so now here's where we can set our params. And this is a request thing here, by the way. So we could say UID, because that's the parameter we need to pass. And then we could say, you know, the value of the UID. And we might need to convert this UID to a string. Let's try it as it is right now, but I'm pretty sure we're going to need to typecast that one to a string. But we'll see. Now, we'll define response, and that's just going to be request.get, and we pass the URL and params equals params, so we can use those parameters that we're creating dynamically. And actually, we have to say self.url, because this is from the class. And once we do that, we want to do a basic check, right? Let's first figure a critical piece of information out, right? Let's just print the response of, we should have printed, ideally we should have just tested this on just our thing here. You know what? I'll actually do that because I'll show you the methodical way to kind of work our way through this, right? So let's just shift everything over here for a second and just test this on ourselves first. So we will say UID equals this value. And then what we're going to be doing is getting the response. We're going to have to do a .text here so we can get the actual response. And now we'll just say, you know, like we've been doing all this time, if underscore name is equal to main. Oops, I'm not sure what happened there. So if that's the case, then we will do API equals API. and then we'll do a API.pwn, right? So let's just go ahead and do that. We'll run this with Python 3. And looks like I am missing a self. Let's see. API.pwn, def.pwn self. What am I missing here? Oh, right. I need to actually include these braces here. So, okay. Yeah, we didn't have to do any typecasting in this case, so that's nice. And as you see here, we got just our information. Now, let's make this more useful, right? Let's see for a second, right? If we change this here, is there anyone here? There's no one there, right? Null. We got null. So let's check the lengths, right? This is us. So if we print the length of the response, because this is how we're going to code this. This is how we're going to script it, right? The length of our data, like when we got the Bob Lucas one back, is 84, right? It's 84 length. And the one that was didn't exist, the null response was 5. So what we could say then is we could simply say that if the length of the response is greater than 5, then we want to print we will print the response. But we also want to throw in an else here, right? Because we want to keep auto incrementing by 1 until we found all of them, right? And so if we ever hit a point where we increment to the next one and there's nothing there, we want to just stop at that point. And we could do all 50, but let's write this more efficiently. So we'll just stop as soon as we don't... as soon as we hit a null, basically, right? So that we could say else, just, exit, right? So if we run this, let me make this window a little bit bigger down here. So we'll run this one, and let's see here. All right, we need to, of course, we're going to need to throw in the for loop once more, right? And have it increment. So let's remove this, and we'll shift everything over once again. Okay, for real this time. And there you go. Here, I'll run it where you guys can see a little better. And yeah, just like that, we found all 5 of these entries here. And that will match up if we go to the actual JSON file, the accounts.json. We can see these were the 5 here. And we're able to brute force all of them by exploiting this IDOR vulnerability. And, this would be just as easy to do in Burp as well if we wanted to. Burp's really good for exploiting IDORs if you have Burp Pro. If you don't, then it's a little hit or miss. It can be kind of slow when it throttles you. But basically, if we were doing that right, we would make the request. Like, it's probably easiest to show it here, right? We'd be making this GET request, and we'd send this to intruder. And we would say right here is the parameter that we're going to change, this value here. And we could create, we could tell it to increment it. And we could pass in, or we could even pass in our own list of numbers that we could try and brute force there. And yeah, we would just hit start attack. And that's how you would do, you would look at the lengths, right? It will show you the lengths. So whichever one had a longer length than 5 is probably going to be someone's account. So that's how you do it through Burp. Just as a little bonus there for you guys. So hopefully you enjoyed this one. I know it was a super basic vulnerability, but it's a very fundamental one to understand. And we'll be moving on to some even cooler vulnerabilities in the future with this series. So definitely stay tuned for that. And, subscribe to the channel if you haven't already. Hit the like button as well. It definitely helps out. And yeah, as always, drop your comments down in the section below. I love to read and respond to them. And if you're really, interested in learning more of this Python stuff and how we can create some Black Hat tools, go ahead and check out my videos on screen right now, Black Hat Python. I'll see you guys right over there. Thanks for watching.